So today I'll present about the cultural space proposed application for my IFO. This is the table of contents. First I'll be doing the introductions, then going on to the case studies to the proposed application. So the purpose of this project is to basically turn the existing space of Rumatangsi to a cultural gallery that can be shared with various populations without bringing its heritage value of the building down. To counter and for my problem statement, I decided to counter the issue of fast fashion and fading culture in Malaysia by designing and creating a space that is more recognized and appreciated by the local community. So Rumah Tangsi was built in 1903 and it was originally a mansion. Right now it's a national heritage which is used for also like conventions, weddings, and even live music performances. As for the current trends, I basically briefed the whole site analysis, talked about the weather of the place, how its traffic is leading to noise pollution, air pollution, and how the weather may pose a threat to the materials, and the humidity from the vegetation may also lead to like structural integrity to be weakened over the years. For the future trends, I talked about how COVID-19 has brought changes to businesses and how spaces operate. This can also lead to social activities being affected around the area, and demographically, it's unlikely to change because it's a heritage building and the businesses and people haven't changed for a long time. And so we may need to bring in a target or a niche market to attract a wider demographic. Going on to the case studies. For case study 1, I'll be talking about humanscapes habitat urban living in Oroville, India. So this project is basically made to state as an example and a standard for low embodied energy buildings in India to combat the global crisis on energy and climate change in India. So they take inspiration from urban vernacular architecture and use a lot of very open spaces. Then this allows a lot of air and sunlight to emit through without by reducing heat gain. So the large windows optimizes air circulation and they're all operable for users whenever they want. And the window shading creates diffuse natural light, whereas like semi-open spaces protect them from like rain and sun. The building also uses a lot of sustainable materials taken from the site itself, and this leads to reduction of new materials used within the space. The local building materials they use are VOC free and have low emissivity, and they use a vernacular technique to revive the flooring. For finishing, they don't use like any industrially processed materials, and they like to bring out the natural textures of all the materials. They take full advantage of India's climate and use photovoltaic cells, which powers up the whole building, and it's mainly used in net for HVAC system. They also use this building to educate the upcoming professionals and other students as well. So going on to the next case study, which is House Under Shadows. Located in India, this building is actually two houses under one roof for two families to live in sustainable way. So in this strategy, you can see that they asked the designer to make a space where two families can live in and be in close connection to each other while having a sense of privacy as well. The homes are like oriented so that it can optimize the sunlight and also cooling features, and the bedrooms are also facing away from the sun so that it doesn't have heat or glare. And the most striking feature of this place is the roof, as it has like these pattern roofs that diffuses the sunlight. And this roof has allowed the place to have 50% reduction in direct and diffuse radiation as well. They also implemented biophilic designs outside and also inside the house, which creates a cooler microclimate. They also designed the place to have a pool, which acts as like a heat sink, which absorbs heat throughout the day and releases heat during the night. And this also affects the ventilation of the place. Next case study is Science Labs and Music Center at Panyadan International School, Chiang Mai, Thailand. So in this project, their aim was to integrate buildings into natural environment using modern engineering knowledge while achieving minimal carbon footprint. They are also built with organic design, which follows the shape of an L, and this improves the airflow into the building. They use very durable, low-E materials such as bamboo for like the roof structure, and this provides also as an absorbing panel for the music building. They also have durable yet biodegradable earth walls, which also provides quite good thermal mass to the building for thermal performance. They also have a lot of ventilation features such as open skylight, airways, and windows. They also have their own fresh air system, and which is supplied throughout the whole structure. They have sustainability teaching programs throughout the whole school, and they encourage students to learn sustainable values and motivate them to build awareness and knowledge and take action. In this comparison diagram, you can see that all the case studies have very similar sustainability factors implemented, and they're very easily to implement. So I could also implement it in my project. Moving on to the design application. So the building is a multi-use space, and it is not only a gallery but also a bar area, workshop, and a retail store. And so this the range of like functionality helps attract like a wider audience to the space as well, and this helps attract more business to the site and surrounding areas. Overall, this economically benefits the area. So the batik workshop area will be run by local batik designers, and this will help them promote their own local businesses, and customers are also allowed to see the workers in action making batik textiles, and this in turn promotes the appreciation for the art of batik making. I also plan to implement photovoltaic cells in order to generate electricity, and this can help on cutting down on electricity and energy costs throughout the structure. And I plan to use monocrystalline cells type of solar panels. Heat and glare was one of the most noticeable issues I felt during the site visit. So in order to battle this issue, I proposed the use of ventilation blocks and slatted facade. The thin layer of ventilation blocks will reduce the glare, and the slatted would also protect the whole building structure from UV radiation, while also providing extra shading for the user. Natural ventilation is also important as it reduces a lot of electrical costs in the long term. And for this project, I use ventilation blocks throughout the facade to reduce heat gain. And ventilation blocks are very easy to install and construct with no maintenance required. The vernacular design elements implemented on the facade and the interior also maximizes the natural ventilation. Implementing the atap roofing, which has low thermal capacity, gives good insulation against heat. The ventilated roof space helps to cool down the upper floor. Open interior spaces with minimal partitions in the ground floor would allow good ventilation and air circulation in the interior. Since Rumatangsi currently lacks any like sort of biophilic elements, I decided to have a lot of plants implemented in biophilic design in it because makes the place more sustainable and improves the human and nature relationship as well. These are the references I use, so thank you for listening.